So coordinate flip results in this. Hello, today we're going to make a diverging bar plot, which handles both negative and positive values in a bar chart. You often see this with economic data based on country, location, maybe the age ranges of countries and where the greatest amount of populations are. But today we're going to use MT cars. And we need to make new columns in MT cars. We're going to call that car name, MPGZ, MPG type. And to do so, we need to add MT cars $. And this will be our column name. And the fact this is in quotes means it's going to make a column without any name there. But in that column, we're going to have MT cars, row names. So it's going to create a new column for the car names. MT cars $MPG underscore Z. We're going to round it. MT cars MPG minus, so the miles per gallon minus the mean of miles per gallon divided by the standard deviation of miles per gallon. So we're going to compute a normalized MPG. So what's the normalized miles per gallon? That's what we want to have in one column. In the other column, we want to do MPG type. So we're going to use an if-else statement. This is going to create our above and below average. So if-else, if MT cars MPG underscore Z is less than 0, quote below, quote above. So if-else, if it's below 0, you're going to have it below or titled above. So if it's below 0, it goes below. If it's above 0, it goes above. That's the ordering here. Lastly, we're going to do MT cars. We're going to order this. We're going to order our bar chart by MPGZ, so that way you have a smooth chart where you have larger bars with larger MPG averages and smaller bars with smaller MPG averages, and it's going to swoop over from positive to negative. Lastly, MT cars car name, we're going to do a factor of the car name. So under MT cars car name, we're going to make levels based on the car name. So therefore, we're going to convert to factor to retain sorted order in the plot. So if you have a car with high mileage, it's going to sort it in that order, and we're going to also be able to point to that larger bar with higher MPG and say, oh, it is a Mazda type, a VW, a Prius, like a Toyota car. So this is all that you need to do in order to create a smooth and cohesive diverging bar plot. Now we can dive into ggplot. ggplot, data sets MT cars. We've already inputted all that we want to in addition to the MT cars data set. Our X is going to be car name, our Y is going to be MPGZ, and our label is going to be MPGZ. We're going to do a bar chart, hence the diverging bar plot. Your stat is identity, so your statistics are going to be based on the car name. Your aesthetic is going to be fill. You're going to fill based on MPG type, and we're going to make the width 0.5. So that's going to be the thickness of the bar. We're going to fill it manual, so that means we're going to choose our colors, naming it mileage, labeling it above average and below average, and the values above equals this green color, below equals this red color. I would encourage you to consider something other than red and green for colorblind friendly color palettes, but it can be your choice. Lastly, we're going to do labels for the entire bar chart. We're going to flip it on its side so that way it is turned 90 degrees and not upright. And I'll show you what I mean. If we didn't do this, our bar chart would look like this. But this isn't an ideal diverging bar chart. This is not typically what you see in a nice diverging bar chart. Additionally, you can't read anything on the x-axis because you can't see the overlapping text. So coordinate flip results in this. So you're going to see those plots above, those plots below in MPG. You can read the car name and you can see the MPGZ, which again is the normalized MPG. So here's how you can make a diverging bar plot. Stay tuned for next week's video on a diverging lollipop chart, similar to this, but slightly different.